So now on to Venus. So as people were first considering what Venus might be like, they realized that it was closer to the sun and therefore might get more sunlight. Well, as we look at the Earth, the region that gets the most sunlight of the Earth is around the equator. And if you've ever been to those regions, these are the tropics. These are regions that are very wet. There's a lot of life. Tropical rainforests occur in these regions. So people started speculating maybe Venus might be a tropical rainforest planet. And the clouds that we see are actually cloud tops of these constantly raining clouds. Well, that was one possibility. Some other people suggested, though, that maybe it was too close to the sun. So close that maybe all the water is boiled off and it's actually a terrible hot desert planet. But without actually going there was no way to really tell which was the case. So the Mariner 2 probe went to Venus, and it did not land, but using radar techniques, it measured a surface temperature of around 400 Celsius. 400 Celsius, 4 times hotter than boiling water. This was then later confirmed by some Soviet landers, which, when upon landing, recorded a temperature of around 460 Celsius. What this means is it is not a tropical paradise planet. It's actually a burning hot, terrible planet. In fact, Venus is the hottest planet. It is even hotter than Mercury. Exactly why that is, we'll talk about in a bit. Well, to get the feel for the surface of any planet, we can make topographical maps. So these can tell us about different elevations. In this case, we're looking at the surface of Venus. So notice our scale, blue is low and red is high. So from this, you can see that there's actually not a lot of red or even yellow on Venus. We have some way at the top and a couple of spots along the equator, but overall it actually has a relatively smooth lowlands surface. Now we do find some craters on Venus, but not all that many, which is going to suggest it's a very young surface. And in fact, the craters that we do see, we are actually being actively destroyed. So in this case, we have a crater with a canyon that is now running through it. So this suggests that Venus is geologically active, with volcanics and tectonics. Based off of the crater counts that we see over the surface, there's no part of Venus that is older than about 500 million years old. Yes, I just said 500 million years like it was young. If you think back to the Earth has ongoing geology, tectonics, volcanism, all that stuff, and yet we can still find patches on the Earth that are 4 billion years old. There's nothing like that on Venus. So Venus must be very geologically active. As we've studied the surface of Venus, we've found what appeared to be 1,600 volcanoes, with 80% of the surface being low-lying smooth lava plains, likely caused from lava flows from these volcanoes. To actually test if these regions are volcanic, the best thing we can do is actually go there. So the United States has never actually sent anything, but the Soviet Union actually had a robust Venus exploring mission with many successful landers. So what we have pictured over here are actually images from the surface of Venus. And what these landers found is volcanic rock, exactly what we'd expect if Venus is volcanically active. Now, exactly how the surface could be so young is still unknown, but the leading idea is that because Venus does not have plate tectonics like the Earth does, that it's not able to get as much heat released from the interior. So what happens is in the inside we have radioactive decay, which is heating the interior up over time. And then that heat isn't able to escape easily. So this leads to some sort of cataclysm. Either the entire surface completely remelts for a period until it releases enough heat from the interior to resolidify, Or maybe we have all of those volcanoes erupt constantly for thousands of years, again, until all of that interior heat is then released. Okay, so some sort of repaving cataclysmic event. Now, another suggestion is that because it's not able to release as much heat as the Earth, this leads to a greater convective cycle within the mantle. And so we actually have these much more vigorous and rapid convection cycles in the mantle. This will then lead to a lot more volcanoes, but in the downward part of the cycle, this will be happening so fast that chunks of the crust literally break off and sink back down into the mantle. Okay, so the crust is literally flaking off into the mantle. This is what is sometimes referred to as flake tectonics. Okay, now in this case, we don't know which one's actually right, so we'll go back to the cool, which one would appear cooler rule. And in this case, I'm going to go with cataclysm. Actually seeing an entire planet remelt is probably going to be cooler than the crust getting destroyed from underneath, although both ideas are actually pretty awesome. So Venus does have an atmosphere. Mercury does not have an atmosphere. It also has no moons. Okay, but Venus does have an atmosphere. In fact, Venus's atmosphere is even thicker than the Earth's atmosphere. It's about 90 times thicker than the Earth's. Now, the atmosphere of Venus is actually mostly carbon dioxide with some nitrogen mixed in. Okay, so it's around 96-97% carbon dioxide, with most of the rest being nitrogen. Now, there are clouds on Venus, as we've talked about previously. However, the clouds are not water clouds like we get on the Earth. Instead, the clouds on Venus are made of sulfuric acid. Okay, there are sulfuric acid clouds on Venus. Okay, now the conditions in the clouds are right to actually lead to sulfuric acid rain. However, the surface temperature is so hot that as this stuff is falling, it will actually re-evaporate, going back into clouds. So I guess the good news is there aren't sulfuric acid seas and oceans on the surface of Venus. Instead, you just have temperatures over 400 Celsius and lots of ongoing volcanoes with rivers of lava. Venus is a bad place. If anybody ever says to you, hey, let's go to Venus, you should say, no, I choose life. Venus is a bad place. Now, although the surface is bad, if you actually notice, so on this graph, we're looking at the altitude through the atmosphere versus the temperature. There is actually this region where we get to about the same pressure as the Earth with Earth-like temperatures, although this is in the upper atmosphere. This has actually led some people to suggest maybe don't land on the surface, but actually create floating cities on Venus, which I have to admit is a super awesome idea. The only downside to that is, notice you're in the middle of the cloud layers, and that's sulfuric acid. So maybe not do that either. All right, so how did Venus get so terrible? Okay, so Venus, Earth, and Mars all formed at the same time, in the same place, and in the same way, so we kind of expect them to be the same. And we actually do think that Venus, Earth, and Mars all were similar really early on. Okay? And there's some suggestion that we actually had water on Venus, that there may have actually been oceans very early on. Now, the problem that Venus had is how close to the sun it was. Okay? So with how close to the sun, it started to heat up. Okay, as it heated, this allowed some of the oceans to begin to boil, producing more water vapor. Then we also have volcanoes, which are going to be producing more, releasing carbon dioxide into the atmosphere. Both of these are strong greenhouse gases. Okay, so we increase the amount of greenhouse gas in the atmosphere, which is going to drive up the temperature, which leads to more boiling of the seas, which leads to more greenhouse gases, and we get into this vicious cycle. Okay, we have a positive feedback loop where it's going to just get hotter and hotter and hotter. So in this way, Venus has actually become the hottest of all of the planets. It is simply because of the greenhouse effect. Okay, so the greenhouse effect can have significant and serious consequences. All right, here is our fourth question. What would happen to the Earth if it was moved to Venus's orbit? A. The atmosphere would be blown away by the intense solar wind. B. Earth would begin to heat, leading to a runaway greenhouse effect, causing it to become as hot as Venus. C. It would cool more rapidly, leading to an end of plate tectonics. Or D. Earth would be unaffected if it was moved to the orbit of Venus. Go ahead and think about it, and we'll discuss it in just a second. All right, so the answer is B. Okay, if the Earth got moved to Venus's orbit, we'd receive more sunlight, things would start heating up, the oceans would begin boiling, which would lead to a runaway greenhouse effect. In other words, don't move the Earth closer to the sun. We're good where we are, maybe push it out a little bit farther if you like colder weather, but do not push it in closer towards the sun. So again, the answer is B.